So in the last notes we took, we looked at finding the GCF of a group of terms, numbers and variables. We all had it all in there. Today we're going to look at factoring a polynomial using the GCF of its terms. And so to factor an expression is to rewrite that expression as a product of its prime factors. So we're kind of breaking these polynomials up into their factors. And now to factor using a GCF, you can think of it as the reverse of the distributive property. So we're going backwards through that process and dividing each term by the GCF. So our process here is just to find the GCF of each term in each polynomial and then divide it out of each one. So for example A, we have 6x and 18. And so to think about that, we know that the GCF there is 6, because 6 is the GCF of 6 and 18. They don't both have an x, so that's all I can do. That's the GCF. And now what I want to do is divide both of those terms by 6. And then just like the distributive property sets our GCF or our number in front of the parentheses, we're going to kind of end up with that format. So if I divide each of those things by 6, and you don't have to write this every time, I'll just do it here so you see what I'm actually doing. We end up with this. We take the 6 out, and then the leftover terms after we divide go in the parentheses. So 6x divided by 6 is just x. 18 divided by 6 is 3. And so this is the factored form of that polynomial. We took out a GCF of 6. What was left over was x plus 3. Let's try the next one. We have 2x squared plus x. Looking across these, I know there's a 1 in front of this one, so the GCF of 2 and 1 is just 1. But they do both have an x. The smallest exponent present is 1, so that's my GCF. I can take out an x. And then just divide each term by x. So 2x squared divided by x, you can imagine it like this. That's just 2x. Essentially just subtracted 1 from the exponent. And then x divided by x, anything divided by itself is just 1. So we took out an x, that was the GCF. We're left with 2x plus 1. It's a good idea after you factor out the GCF to just take a look at what you have left over. In this case, it's 2x and 1. And just double check and make sure that there isn't another factor you can take out, that you really did get the GCF the first time. So if this was something like 4x plus 2, I could know that I should take out another 2 from those two terms. So it's always good to double check. Okay, example C, 3x squared plus 15x. So first we find the GCF. The GCF of 3 and 15, I know 3 goes into 15, so that's our GCF there. And they both have an x, and our smallest exponent present is 1. So that's our GCF, 3x. But we're going to divide each term by 3x, just like this. So 3x squared divided by 3x, well, these cancel out. 2 minus 1 is 1, so that's just x. 15x divided by 3x, well, 15 divided by 3 is 5. And x divided by x, those cancel out. So 3x times x plus 5 is our factored form. Example D, we have 3 terms this time. That's okay. Looking across, we have 2, a negative 1, and a 1. So 1 is really the GCF for that one. And then they all have an x. The smallest exponent present is 1, so x is our GCF. And just go through it. X, divide everything by x. So really what this is going to do is reduce all those exponents by 1. So we get 2x squared minus x plus 1. Now for example E, something to notice here is our leading coefficient, the first coefficient in our standard form polynomial is negative. So we want to include a negative in the GCF just so our leading coefficient ends up being positive. So between 25 and 15, The GCF there, well, that's 5. I know that 5 is the biggest number that goes into both of those. And we do want to take out a negative 5, so let's do that, negative 5. Now for v cubed and v squared, they do both have a v. 2 is the smallest exponent there, so that's my GCF, negative 5v squared. So now we're just going to divide each of those by negative 5v squared. So just divide the coefficients and then subtract the exponents. So negative 25 divided by 5 is positive 5. 3 minus 2 is 1, so that's 5v for that first term. And then we're going to add to that, divide 15v squared by negative 5v squared. So actually we get a negative 3. If you're ever not sure if you divided correctly, you can just go through and do the distributive property and check it. We get negative 25v to the third plus 15v squared, and that is what we started with, so we know the answer is correct. The factored form for that problem is negative 5v squared times 5v minus 3. Okay, example F. 50x to the 7th y to the 5th plus 80xy to the 4th. So between 50 and 80, I'm pretty sure the GCF there is 10. If I divide 50 by 10, that gives me 5, so that's a prime number. 80 divided by 10 is 8. 5 doesn't go into 8, so there we go. 10 is the GCF here. They do both have xy, so I know they'll both be in my GCF. Smallest exponent on x is a 1. Smallest exponent on y is a 4. There's the GCF. And again, to factor that out, just divide both terms by that GCF. So divide the coefficients, subtract the exponents. 50 divided by 10 is 5. 7 minus 1 is 6, so x to the 6th. 5 minus 4 is 1 for y. Plus 80 divided by 10 is 8. 1 minus 1 is 0. Those x's just cancel out. 4 minus 4 also, those exponents cancel out. So all we have for that second term left is just 8. And there's your factored form for example F. Example G, negative 30r to the 6th minus 10r to the 3rd minus 90r squared. Looks like 10 again, and they are all negative, but particularly this leading coefficient is negative, so let's take out a negative 10. And they all have r. 2 is the smallest exponent, so r squared is what we want. Okay, now we divide. Negative 3 divided by negative 10 is positive 3. 6 minus 2 is r to the 4th. And again, we are dividing by negative, so these will all turn positive. Plus, 10 divided by 10 is 1, and 3 minus 2 is 1, so we get r. Plus, 90 divided by 10 is 9, and the r's cancel out. So there's our factored polynomial there. Okay, example H, again, leading coefficient is negative, so that's what we'll use. And looks like our GCF is going to be negative 2. They don't all have x, so that's it. Let's divide. This just leaves us with x squared plus 4x minus 4. If they don't all have x, you can't use it as your GCF. Leave it out. Last one. We have 24, 24, and 16. Pretty sure that would be 4. Well, actually, there's one bigger. So, but let's say that I thought that it was 4. And I'll go ahead and do some quick factor trees here. If I divide by 4, I'm left with 6 on these and 4 on this. Now I can keep going. Leave the 4s alone. That's what we know they have in common so far. 6 is 2 and 3. 4, this 4 is 2 and 2. So they all have at least one 4 and one 2. So 4 times 2 is 8. Our GCF here is 8. So my initial thought was 4. Always good to double check. You know, you can do a quick prime factorization, a quick factor tree with 4, because I know that 4 goes into all 3 of those. See what's left over. I could keep going on the 4 on the 16. That did give us an extra 2, so 4 times 2 is 8 for our GCF. First term is negative, so we should put a negative 8 on that. They don't all have a. This 16 does not have an a, so that is our GCF. So to divide that, we get 3 a to the 4th plus 3 a to the 3rd plus 8. And there's our factored form there as well. Okay, so after you find the GCF, divide each term by that GCF. Just make sure you also write it as part of your answer, followed by the leftovers after you divide. So it's the GCF and then in parentheses, the polynomial after you've divided that GCF out.